Good morning, everyone. On the previous turn, you learnt about Pythagoras property of a right angle triangle, which is also popularly known as Pythagoras theorem. So let's recall that before we continue with the exercise. Pythagoras property of a right angled triangle. So it says of a right angle triangle. That means the property applies to a right angled triangle. I hope you all know about a right angle triangle. Here you can see a triangle in which one angle is given a right angle, that is 90 degree. So in a triangle, if an angle is a right angle, then it's called a right angle triangle. And then you have the side opposite to this right angle. So this is a right angle, and the side opposite to this angle is this highlighted here, and this side is called hypotenuse, right? So this side, the side opposite to right angle, is called hypotenuse. And you must also observe here that this is the longest side of the triangle. So hypotenuse is the longest side of the right triangle. So this way also you can recognize it, that hypotenuse is the longest side. So whatever shape, whatever view of the triangle is, just remember that the side opposite to right angle is the hypotenuse, that is the longest side. Now what about the other two sides? The other two sides are called perpendicular, or the height, and the base. So this means that this side will always be the height, or this will be the base? No, we can also call this side as base. Just look here. This side also can be called as base, and this side can be called as perpendicular. So since both the sides are perpendicular to each other, so we can call the two sides containing the right angle. So here you can see that this angle is given right angle. So the sides containing, that means this side, just look here again, this side and this side, they both contain this right angle. So these two sides will be called perpendicular to each other. So we can call them one side as perpendicular and the other as base. So any one side can be called perpendicular and the other side will be base. Now what is Pythagoras property or Pythagoras theorem? So let's see. So in this triangle ABC, the square of the longest side, that is hypotenuse, is equal to sum of square of other two sides. So Pythagoras property of the triangle says that square of the longest side, that is square of hypotenuse, is equal to square of the other two sides, their sum. So AC square is the hypotenuse here, square AC square equal to AB square plus BC square. That means hypotenuse square equal to square of perpendicular, or the height, plus square of base. So in any right triangle, square of the longest side is equal to sum of square of other two sides. Now open exercise 11.5 of your book. Open your books and look at question number 5. The question says a 15-meter long ladder reaches a window 12-meter high from the ground on placing it against a wall. How far is the foot of the ladder from the wall? So if you read the question, nowhere it is written that it is a question based on Pythagoras property. But now since you are having questions based on application skill, so this is one example of application skill based question. Now here the question says there is a 15-meter long ladder which reaches a window 12-meter high. So look at the figure here. Here in this case, this is the ladder. This is the ladder, right? This is the ladder, and you have this ladder reaching on a wall. So this ladder is reaching 12-meter high on the wall, and it reaches a window. So you can imagine that A is a point where it reaches the window, which is 12-meter high. So here you have a wall. So you have a wall here. This is the wall, and this is actually the window they are referring to. This is the window. So I hope it is clear now. The ladder is reaching a window on a wall which is 12-meter high, and the length of the ladder is 15 meter. So this is actually application of Pythagoras theorem in real life situation. Now let's see how to proceed. Now since it is forming a right triangle, because the wall is straight, so since the wall is straight, you will have this angle a 90-degree angle, right? So this angle is 90-degree. So it's a right angle triangle formed here. So we can apply Pythagoras property in this triangle. So let's see the solution. Now according to Pythagoras theorem or property in this triangle ABC, we can write AC square equal to AB square plus BC square. Now let's put the value. AC is the hypotenuse, which is in this case length of the ladder, that is 15. So we place the value of AC, that is 15, and AB is the height of the window, that is 12, and BC is not known, so let BC be X. So they are asking how far is the foot of the ladder. The foot of the ladder is here. So foot of the ladder is this at C point, and this is the foot of the wall. So they are asking the distance between B and C actually. So that we denote by X. So we are denoting this thing which they are asking by X. So this is X. So let's place the values and let's find the value of X from this equation. So we have X square equal to 15 square minus 12 square. Now X square is 15 square 225 minus 144, and X will be under root of 81, and under root of 81 you will get as 9. So x is 9 meter. That means foot of the ladder from the wall is 9 meter. That is a. Now look at question number 6. Find the area and perimeter of rectangle whose length is given 15 centimeter and length of one diagonal is given 17 centimeter. So look at the figure here. Here is a rectangle whose length is given 17. So these two are the lengths, and this are the breadth. Now you know all the angles of a rectangle are 90 degree each. So this angle is 90 degree. This angle is 90. So that way actually this triangle becomes a right triangle. So we have this triangle, a right triangle. So we can apply Pythagoras property to this triangle. So let's write according to Pythagoras property. Now since here this angle is 90 degree, so the side opposite to this 90 degree is hypotenuse, which is in this case the diagonal of the rectangle. So if we apply Pythagoras theorem, we can write hypotenuse square, that is d square, equal to sum of a square of other two sides, which is L and B. So d square equal to L square plus B square. Now let's put the values here. Diagonal is given 17 centimeter. So replace d by 17. 17 square equal to length is given 15. So 15 square plus B square. Let's solve this. So B square equal to 17 square minus 15 square, which we get as 289 minus 225, and hence B square has come 64. So B will be under root of 64. That is, now we factorize 64, we get the factors and we pair them to get the value of the B, which is square root of 64. You know the pairing. So we got 3 pairs of 2. So B is 2 into 2 into 2, that is 8 centimeter. Now we got the breadth of the rectangle. Length is already given in the question. So we can find the area. Area of the rectangle is length into breadth. So place the values of length and breadth. 15 multiplied by 8, that is 120 centimeter square. Now perimeter of rectangle, you know, is twice length plus breadth. So let's place the value of length and breadth 15 and 8, and we get the perimeter of rectangle as 46 centimeters. So area is 120 centimeters square and perimeter is 46 centimeter. Now let's see question number 8. The side of rhombus is 5 centimeter. If the length of one diagonal be 8 centimeter, find the length of other diagonal. You know what is a rhombus? A rhombus is a four-sided figure whose all four sides are equal. So you must be thinking about a square. A square also has all the four sides equal, but a square has all the four angles also 90° each. But in a rhombus all four sides are equal, but each angle is not 90°. Instead, in a rhombus there is a property that diagonals bisect each other at 90°. So this angle denoted here by highlighted here is 90°. In between the diagonals we have 90°, and diagonals bisect each other. Bisect each other means this equal to this, and another diagonal is also bisected. So this denoted by double lines are equal. So both the diagonals are bisected. So since length of one diagonal is given 8 cm, so suppose AC is 8 cm, so AE will be 4 cm, half of it. Since the diagonal AC is divided in two halves, so AE will be half of AC, that is 4 cm. Now another diagonal you have to find the length. So let's DE be denoted by X. So we are denoting what is missing here as X. So this we denote by X. Now let's see how to write our solution. So AE, as I explained in the figure, is half of the diagonal. Since the diagonal is bisected, so half into 8, that is 4 cm. So AE has come 4 cm. Now since this is a right angle triangle, this is a right angle triangle AED, so we can apply Pythagoras property to this. So in triangle AED, according to Pythagoras property, now here we have this angle, as 90. So the side opposite to this is this, which will be considered as hypotenuse. That means AD will be the hypotenuse. So according to Pythagoras theorem, now we can write hypotenuse square, that is AD square, equal to AE square plus DE square. Now let's place the values here. AD is 5 given and AE is 4. So we write 5 square equal to 4 square plus x square, and x square will be 5 square minus 4 square, that is 25 minus 16, that is 9. So x square has come 9. So x will be under root of 9, that is 3 centimeter. Now BD is twice of D, or you can say D is half of BD. So since D is half of BD, so BD is twice of D. So twice of D means 2x, that is 2 into 3, that is 6 centimeters. So since we found x, we can find BD also. So we got BD as twice of B, that is twice of x, and that is we got BD as 6 centimeter. Hence the length of other diagonal is 6 centimeter. Thank you.